Welcome. Today, let us take a new chapter, vector. Today, it is first part of that chapter. First of all, we discuss only few important definitions and results of the chapter vector. If any vector makes an angle alpha, beta and gamma with the axis, then cos alpha, cos beta and cos gamma, this trio, they together is known as direction cosine of the vector. Normally, it is denoted by L, M, N. Normally, this is denoted by LMN. It is direction. Actually, it is normally called direction cosine. C stands for cosine. Any constant multiple of direction cosine means, say, 2L, 2M, 2N, all are multiplied by 2. It is a direction ratio. 1 by 4L, 1 by 4M, 1 by 4N, this is also direction ratio. So, corresponding to a particular direction cosine of a vector, it has infinitely many direction ratio. Direction ratios are normally denoted by A, B, C. For a given vector, if ABC is the direction ratio, from it we can calculate its direction cosine, which is unique. It is equal to, suppose, root over of a square plus b square plus c square is equal to k, say, k, root over a square plus b square plus c square. Then a by k, b by k, c by k, it is direction cosine of that vector whose direction ratios is this. For direction cosine, it has one property, very important property, which is nothing but L square plus M square plus N square, it will always be equal to 1. L square plus M square plus N, that is cos square alpha plus cos square beta plus cos square gamma must be 1. The position vector of any point means, suppose this is a point, say A. O is the origin. It's, suppose, A1, A2, A3 is the coordinate of the point A. Then the vector OA, O is origin, O joining O to the point OA, this is known as position vector of A, and this is normally A1I plus A2J plus A3K. I, J, K, these are unit vectors along the axis. That is, unit vector along x-axis is I, along y-axis is J, and along z-axis is K. So suppose position vector of a point A, which A and B is another point whose position vector is b. These two position vectors. Then position vector of a point, this is A, this is B, O is somewhere there. Suppose P is the point which divides internally AB in the ratio m is to n. Then the position vector of the point P which divides AB internally in the ratio in m is to n, then position vector of P is n into A plus m into B by m plus n. This is actually exactly same like coordinate geometry. There is a formula for finding the external point P which divides AB in the externally in the ratio m is to n. In fact, in that case, it is mb minus na by m minus n. Simply, n is replaced by minus n. This is also same as in coordinate geometry. Next, the projection, suppose this is a vector, this is another vector. This vector is A, this vector is B. Projection of A on B. Projection means from this endpoint, perpendicular is drawn on that, perpendicular is drawn on that. So this is projection of A on vector B. Say, suppose it is A to B, and projection of A along B, it is simply this one is A dot B divided by magnitude of B. So now let us, before defining that, we have to define what is dot product. A and B are two vectors, then their dot product, for any two vectors, it has two type of product. One is dot product and other is vector product. Dot product is defined as magnitude A into magnitude B into cos theta, where theta is the angle which makes the vector A with vector B. Suppose this is A vector, this is B vector. So if this is theta, this is along A, this is along B, this B vector, it is A vector. So angle between A and B is theta, this theta. Then A dot B is equal to magnitude A into magnitude B into cos theta. The result is, this is scalar quantity, this is another scalar, this is also scalar. So the result is scalar. That's why it is normally known as either dot product or scalar product, as because its result is a scalar quantity. So then next, next one is A is a vector and B is another vector. Then component of A along B, A is a vector, B is another vector. Component of this vector along that vector is A dot B into B by magnitude B, unit vector. And component of A perpendicular to the direction B, this is equal to A minus A vector minus this. Next we discuss vector product or cross product. Suppose A and B are two vectors, then like dot product or scalar product, it has another type of product which is known as cross product or vector product, and it is denoted by A cross B. This is equal to magnitude A, magnitude B into sine theta into n. N is a unit vector, and ultimately this is scalar, this is scalar, this is scalar, but this is vector. So the result is vector. So this is that, for that purpose it is known as vector product. Now these are known to us. Theta is the angle between the vector A to B. Suppose this is A and this is B vector, and this can be taken there. It is A, this is B. So this is the angle theta. So sine theta, up to sine theta we understand. And what is n? N is a unit vector perpendicular to the plane containing the vectors A and B. A and B, these two vectors are lying on that board. So n is a vector perpendicular to the plane containing A and B, that is perpendicular to the board. It is either this direction or opposite to that. Which direction? Actually, direction is, if a right-handed screw rotate from A to B, movement of the head, either it is for that one movement, if its movement will be towards this, and this is our n vector. If we multiply B cross A, n will be from B to A. We have to rotate. We have to rotate one right-handed screw from B to A. So here its head movement will be towards that. In that case, this n for A cross B, this n, and for B cross A, just opposite side. So automatically A cross B is equal to minus B cross A. Next, if component, when A and B are two vectors, their cross product just now I defined. It is if A is given in terms of its component, that is A1i plus A2j plus A3k, and B, its component is B1i plus B2j plus B3k, then A cross B also can be defined as I, J, K. This is a determinant. First line I, J, K, unit vectors. In second line, it will be component of A, that is A1, A2, A3. And third line, component of B, B1, B2, B3. So A cross B is equal to that. And clearly, you see, it contains I, j, and k, which is unit vectors along axis. So it is a vector quantity. If try to multiply B cross A, then in this second line component of B and third line component of A, so two rows in determinant interchange, so automatically one negative will appear. So next, scalar triple product. A, B and C are three vector set. Then A dot B cross C. B cross C is a vector quantity, like that, vector quantity. This is a vector quantity. A dot product of two vector quantity, it is a scalar quantity, and it is normally it can be written as A, B, C. And in terms of components, it is the first you have to write in first row component of A, second B, B1, B2, B3, C1, C2, C3. This is scalar triple product of A, B and C. Three vectors A, B and C will be coplanar, that is lying in same plane, provided A dot B cross C, that is this, is equal to 0. That is if A, B, C is equal to 0. Achha, now let us take some problems. Okay. Take the first problem as ABCD is a parallelogram. ABCD is a parallelogram, and whose coordinates A, coordinate of first vertex A is 1, 2, minus 2. B, 3, 1, 2. C, 4, 3, 1. Then find coordinate of the fourth vertex D. Suppose this is the parallelogram ABCD. Coordinate of A, B and C are known. Suppose coordinate of D is A, B, C. In plane geometry, we know that for any parallelogram, diagonals meet at their midpoints. Diagonals meets at that point, say it is O. It is midpoint of AC as well as O is midpoint of BD. So O, the midpoint of AC is equal to, it is midpoint of A and C, this, so that it is equal to, its position vector will be 1 plus 4 by 2, that is 5 by 2, comma 2 plus 3, 5 by 2, minus 2 plus 1, that is minus 1 by 2. Again, coordinate of O, which is midpoint of B and D, it is equal to, B is 3 plus A this BD. is equal to B and D. 3 plus A divided by 2, 1 plus B divided by 2, and 2 plus C divided by 2. We know that this and that both are coordinate of same point. Therefore, we must have 5 by 2 is equal to that. That is 5 by 2 is equal to 3 plus A by 2. 2 cancels, so A is equal to 2. Similarly, from this, B is equal to 2 cancels, B is equal to 4. And C is equal to minus 1 minus 2. So this is minus 1 minus 2 minus 3 by 2. So 2, 4 minus 3 by 2 is the coordinate of, this is equal to that, 2 cancels. So C is equal to minus 3, not by 2. So answer is 2, 4 minus 3. Our next problem. Position vectors of A, B and C are 2i minus j plus 9k. That of B, it is equal to 4i plus 2j plus 4k. And that of C, 10i plus 11j plus ak. A is an unknown constant. So position vector of 3 points are given. If A, B, C are collinear, then A is equal to what? Options are 4 minus 6 minus 11 and 10. These are the options. What is the question? Now we are given position vector of 3 points A, B and C. That is, coordinate of A is 2, minus 1, 9. Similarly, that of B and C we are given. Given that they are collinear, means they lies on same straight line. Suppose this point is A, this is B, this is C. So vector AB will be some multiple of k, not k is given there, say t into BC. AB vector must be equal to some constant of BC. AB is equal to some constant into BC or AC. You can take AC also. The AB vector, how much? AB vector, it is equal to position vector of B minus position vector of A. Position vector of B minus position vector of A. So that it is equal to this minus that. It is equal to 2i plus 3j minus 5k. BC vector is equal to position vector of C minus position vector of B is equal to position vector of C minus position vector of A. This is equal to 6i plus this is 9j plus A minus 4 into k. As per condition, this must be some multiple of that. That is, in that case, component ratio of component of I, j and k must be same. That is 2 by 6. I component is 2, I component of that is 6. This must be equal to this by that. 3 by 6 must be equal to minus 5 by a minus 4. In fact, this is 1 by 3, this is 3 by 9. 3 by 9. This is 1 by 3, this is also 1 by 3. So it must be equal to 1 by 3. So as per condition, minus 5 by a minus 4 must be equal to 1 by 3. That is minus 15 is equal to a minus 4. So a is equal to minus 11. So this is correct option. Now, our next problem. ABC is a triangle whose coordinates of the vertices are, so ABC is a triangle. Coordinate of A is given as 3, 1, minus 2. Coordinate of B is 7, 2, 5. And that of C is 5, 6, 1. If D is midpoint of BC, D is midpoint of BC, then unit vector along AD, unit vector along AD. Suppose this is A, this is B, this is C. So D is midpoint of BC. B and C are given. So coordinate of D will be midpoint of B and C. That is this plus this divided by 2. It is 7 plus 5, that is 12 by 2, it is 6. 2 plus 6, that is 8 by 2, 4. 5 plus 1, that is 6 divided by 2, 3. So coordinate of D is known to us. We have to find the vector, unit vector along AD. AD vector, it is position vector of D minus position vector of A is equal to, position vector of D means 6i plus 4j plus 3k minus that of A 3i plus 1 into j minus 2 into k, so that it is equal to 3i minus plus 3j. This is 3 plus 2, 5k. AD vector is 3i plus 3j plus 5k. This vector A to D. We have to find the unit vector along A. Magnitude of AD, its magnitude is root over of I component whole square, that is 3 square, j component whole square, 3 square plus 5 square. This is equal to root over of 9 plus 9 is 18 plus 25. it is equal to root over of 43. Therefore, unit vector along AD is, this one is 3i plus 3j plus 5k whole divided by root 43. Oh, so answer it is 3i plus 3j plus 5k divided by root 43. This one. Options, again I have forgotten it. This is third option. Next. Next problem is one vector makes angles 45 degree with x-axis, 60 degree with y-axis, then the angle which it makes with z-axis. It makes with x-axis, y-axis, then we have to find the angle which the vector makes with z-axis. Options are 60 degree, 120 degree, 60 degree or 120 degree and 45 degree. Answer is either this or that or this together or this. Now assume that it makes an angle theta with z-axis. Therefore, its direction cosine LMN are cos 45 degree, cos 60 degree and cos theta. So that it is equal to 1 by root 2 half 1 by 2 and cos theta. We have to find theta. We know that L square for any vector L square plus m square plus n square is equal to 1. It gives us this square plus this square plus this square is 1. So 1 by 2 plus 1 by 4 plus cos square theta is equal to 1. So cos square theta is equal to 1 minus this plus that, 3 by 4. It is 2 by 4, 3 by 4, 1 by 4. So cos theta is equal to plus minus half. If cos theta is equal to half, then theta is equal to half means it is 60 degree. If cos theta minus half, then theta is equal to 120 degree. So the vector makes angle with z-axis either 60 degree or 120 degree. So this is our correct option. Next, if the vectors A, B, C, they are coplanar, then, and given that A is equal to A vector is, position vector of A is 8i minus j plus 3k. Position vector of B is equal to I minus 2j plus 3k, and position vector of C is equal to 2i plus j plus mk. Then what is the value of m? Options: 4, 2, minus 2 and minus 1. So here the problem is actually three vectors are given, with three points are given, and actually three vectors are given. This is a vector, this is vector, this is vector, and given that they are coplanar, then in the component of C vector, one unknown is m. We have to find that value of m. If the vectors are coplanar, then any one vector can be expressed as linear combination of the other. That means A is equal to S into B vector plus T into C vector. S and T are different scalars. So A vector means 8i minus j plus 3k is equal to S into B vector I minus 2j plus 3k plus T into, this is 2i plus j plus mk. So we get this is equal to that. In that equation, T and S are unknown constants. So actually, if this is true, then I component from both sides, j component from both sides, and k component of both sides must be same. That is, we must have 8 I component is equal to S plus 2t. Number 1, j component is minus 1 is equal to minus 2s plus t. Second one, and third one is 3, k component 3 is equal to 3s plus mt. So three equations must satisfy simultaneously. Now let us solve for 1 and 2. In that case, accepting S and T, all are known quantities. So we have, you see, this one can be written as multiplying both sides by 2. 16 is equal to 2s plus 2t. Oh, 16 is equal to 2s plus, no, not that. It is actually 2t here, this is t. Multiply this by 2 and subtract. 8 is equal to s plus 2t. Multiply this by 2. Minus 2 is equal to minus 4s plus 2t. Subtracting this minus that, 10 is equal to 5s. And this will cancel. So s is equal to 2. Putting s is equal to 2 either in 1 or in 2, s is 2. So that 8 is equal to 2 plus 2t. So that 2t is equal to 6. So t is equal to 3. So solving 1 and 2, we get s is equal to 2, t is equal to 3. It must satisfy it because all will be satisfied simultaneously. Now putting this value of S and T in equation 3. Equation 3 gives us 3 is equal to 3S. S is 2. 3 into 2 plus M into T. T means 3. So that we get 6 plus 3M. So that 3M is equal to 3 minus 6 minus 3. So that M is equal to minus 1. This is answer. So option D is answer. So today is up to this. I request you to share my video, like my video, and subscribe my video. Thank you.